We're going to do experiment 4. So already on the board, which is the Resistors Network. Alright, so as you know, for every experiment that we have in the lab, there's a different circuit diagram, and of course there are different aims to the experiment. So for today's experiment, which is the Resistors Network, you'll be given 5 resistors that will be connected, that will be interconnected in that particular circuit. Then we'll be measuring the corresponding voltages and the corresponding currents that will be flowing through and across these resistors. The aim basically is to do or to investigate what will happen when those particular resistors, when those 5 resistors will be interconnected. What will happen? Meaning that the measurement of voltage and currents, how are they going to vary? How are they going to relate to each other? So, as you can see on the circuit diagram, which is on the board, we have 5 of those resistors connected. They are interconnected. We have R1, we have R2, R3, R4, and finally, but not the least, R5. All of them have different resistances. They have different resistances. For your R1, we're going to be measuring it. For your R2, we're going to be measuring it just like we have been doing for previous experiments. During previous experiments, we have been measuring these resistors that will be given to you. But unlike those ones, we are having more resistors this time around. And that's where the name comes from. Resistors Network. Now, the R1 we'll be having will be 9.89. We'll be measuring it. Okay? The same thing will go for R2. And then we'll be having for R3, R4, and then finally the R5. Now, you can see the direction of current, how the direction of current flows from positive to negative in this circuit diagram, okay, that has been designed. This simple circuit diagram is what we're going to implement in the lab. No breadboard will be used. No experimental circuit board will be used. We have the resistors, we have our connecting cables, as you can see, the apparatus that will be given to you in the lab, your DC power supply, you will be having the 5 resistors, then your digital multimeter, which you obviously know, and then your connecting cables. So please give us what was given to you in your report. What we're giving to you here in the lab, will give it to us in your report. Don't do otherwise. Are you guys here? Now, good. So you can see the direction of current. Now for the R1 that is connected, one end of R1 is connected to the other end of R4. You can see this. This is here. We have the R1 here connected to R4. Now this is I1. You can see the current flowing. Look here. You can see the current flowing here. Stop looking at what you're looking at. Look at the board, please. This is for your own good and for your interest. You have the I1 flowing in through here from the power supply, the positive terminal of the power supply, flowing in through R1, and then it keeps going. Now, this is R4. Sorry, this is R4, yes, and then we have I4, and we have the corresponding voltages across this R4. Now, when this there is a unique stuff that is going to happen here. Now, a particular current of a certain value will flow in through I1. But once it gets to this node, now this is a node. A node is what? Like the point where 1, 2 or more circuit elements meet. That's what you call the node. And when this C node here, when the current comes in here, comes to this junction, this point, okay, it splits. Now, depending on the resistance of that resistor, some parts will go in here, and some parts will flow down here because three resistors are interconnected at this point. So, depending on the resistances of these resistors, this one will flow in here. Some will come in here, some come in here as well. Now, this particular current that comes in here definitely will flow through R5. And then it gets to D node, the D node, the combination or summation of the current that flows in through R3 we merge with I4, that's the current, and then both of them, the summation, will flow into I2. We're going to experimentally see those things. We're going to experimentally see it when we carry out the experiment, the measurement. We're going to be measuring it, we're going to be seeing it. And at the end of the day, we then know what has happened this time. Because it said, this is future tense, right? What will? We want to investigate what will happen, basically. What happens when these are interconnected? Alright? What happens when these are interconnected? You have to be very careful. Don't come late in the class. Next, don't come late. Now, because it distracts others, to distract the teacher as well. You have 6 notes, if I'm not mistaken. 6 points basically. We have 2 notes actually. We have this and this. Then, but we have the A, B, C, D, E, F. Okay? But these 2 are the ones basically you'll be seeing some. I'm going to be seeing some analysis, more analysis on them, more references on them. Both of them, the C and D note. So I'm going to indicate it here. Notes. Okay. We need to read. Let's make it down here. And note C. We have what? I1 is equal to what? The summation of I3 plus I4, right? For here, right? Note C, right? Summation of these 2 will give you this one, right? Because, yeah, you get the certain value of current that will flow in here will be splitted. This guy, some come in here, some come in here. Okay? Then, for your node D, these are the ones, like I said, we are looking at. The node D, you have the summation. I2 will now be the summation of I3 and I5. So node D will be is I2, so summation of what? I3 plus I5. So you're going to be seeing these things experimentally again. These things are just theoretical. I'm just showing you that this is this, but experimentally you're going to be seeing it in no distant time. Okay? So now let's work with this right now. Let's start off with the experiment. So just a bit so that you can be able to see just at the edge. Now, just like the way we've been measuring our resistances. Hello, please, you guys stop writing. Let's do this. Stop writing. Just the way we have been measuring the resistances of the resistors from experiment 1, 2, 3, the same way again. So this is our what? R1. What do you know this one as? R1. So we connect. We are going to connect since we are looking for the resistance. Then we interconnect them. Okay? So we're going to find out the resistance. Ohms. What's it giving you? 9.88. Thank you very much. So we put it here. This is the measured value. So this is R1, R2, R2, R5. So for the resistance, 9.88. Let's do for 2. Remember that your values, the SI units are there. Let's do for 2. We put it out. We do for R2. This is R2. What's it giving you? 9.89, right? Good. Okay. To that. Okay. 9.89. It's closely almost the same, but slightly different. Then check out R3. This is R3. separate resistors with different resistances. It's too long. Let's change it. Shorter cable. What are we having? 0.99. Thank you. 0.99. R4 again. This is R4. Let's change the cable. R4. What's it giving us? 97. Okay. Alright. 9.97. Then R5. This is it. The last but not the least resistor before we start interconnecting. What are you seeing?
0.06.
What are you seeing? 0.06. Okay, thank you. 0.06. Alright, let's do the interconnection now. So, according to the circuit diagram, like I said, all the experiments we've been having, 1, 2, 3, and now 4, we follow the circuit diagram. Am I correct? Good. So just like the previous ones, we're going to follow the same thing today again. So, according to your circuit diagram, one end of R1 is connected to the positive terminal of the power supply, right? Right?
Yes.
Good. Now, another end of R1 is connected to which resistor? Tell me. R4 and R3. Very good. Nice. So, we find it. Please look at what I'm doing here. It can be quite confusing because, as you can see, lots of cables. So please, we need to be very careful. So this is R3, but I need to make the cable for R3 shorter because it's going to be in the middle of the circuit diagram. So we don't need to make it too long. So we need to make the cable shorter. So we're going to put these two aside. Then find a very short cable. I have it. Okay. And this. Makes sense. So we have this is R1. So R1 is to be down here, you know, to be down, right? It's in the middle, so it's down, right? So and then R4. This is R4 here. This is R4. Okay. So remove this one and then put one of those. Okay, this guy. Then put here and then here. Yes. So, this is R4, we connect it on top of this guy. So you see, it's coming together, right? It's coming together, am I correct? So, one end of R4, tell me, the other end of R4, which is loose now, where is it connected to? Tell me, according to the circuit diagram. Tell me. Thank you very much. Is it R5 or R5? You know it sounds, you understand? R5 is a question, I'm not sure. But R5, set it. Good. So, this is R5. This is your R2. Thank you very much. So one end of R5, right? So that means we're going to disconnect this guy. One end of R5. You know, we can actually put the cable and then start plugging, but they are too much. So if you do it still the same, it's still the same thing like this. You get it, right? So that the other end of R5 will be connected where? Tell me.
R3 and R2.
R3
and R2.
Yes, R3 and R2. You are next to answer the question. Nobody should say anything. So we connect. And then R2, right? So that means this guy should be on top because initially was beneath. Why are you looking? Why are you guys confusing me? So, and then there's a load here. So this R2, right? Then it's connected here. And then the other end of R2 is connected where? Tell me. To the power supply. Yeah, which terminal? The power supply. Are you seeing it? You are right, it's connected to the power supply, the other end. But which part of the power supply? Is it the positive or negative?
Oh, the positive.
Check. Look very well.
The negative.
Thank you. Negative. The other end of R1 is connected where? Positive. Very good. And this is your complete circuit diagram. Look. Stop talking. Not you, my brother. He knows himself. Yeah. So you can see. So you can see the table, right? So that's how it looks like. You can see from there, yes. Okay, so now we'll now start measuring the voltages across and then the current that flows in through these resistors. Alright? So first and foremost, what are we measuring? I1, right? I1. So to measure I1, what do? Just like we have, I'm going to call on you guys, of course, to come and measure. So just like we have been measuring the previous ones, you still do the same. So for I1, you said for I1, where's I1? Yeah, that's I1. So you look for I1, you just detach. Look at what's going on here. Stop writing, please. This is an experiment. It's not a theoretical class. You need to see what's going on so that you understand what you're writing. Okay? See? You see? Just the way we have been doing now. We did for the previous, this is how you measure current, right? It's current. So we put it here. Well, this one is the positive, right? MA, the red port, then the common port, black. Look for 20, right? Now, the reference voltage. What's your reference voltage that is on the table? Thank you very much. Yeah, thank you. Five. Madam, please, could you help us set to 5? Yes. High level, right? It's correct, right? High level. It's correct, high level, right? 5. Okay. Only this guy and then. So, tell us. Speak out. Speak out.
0.22.
Say again.
0.23.
0.23. Thank you very much. 0.23. Now, I'm going to measure I2. I'm going to do I2 again. So I'm going to do I2 now, not again. And then the same concept, I'm going to call somebody to come and measure. Now, after doing that, you just remove. Yeah, please help us on that. Thank you very much. You put it back. Now, this is I2. The same way I did this one. Where is I2? We check for I2, I2. There you are. Yes. I2 cannot hide from us. You see, this is I2. Again, detach. You see that? Just one end. When you detach, you hold it. The same thing you do for all these guys. One end detach, connect a cable. Connect. See? Then you check which one is the positive and negative. This one is the negative. This is positive. The multimeter. So turn it on. Turn this guy on. What's giving you, madam? 0.23 again. Alright, problem. All these things, mathematically, you are going to see it. 0.23. Now I'm going to call somebody. Come. Let's do I3. Okay? So we turn it off. Turn this one off again. Then we disconnect. Wait, sorry, which one? Yeah. We disconnect to avoid confusion. Put this one back. And the circuit is complete again. So I3 is what we want to do now, right? I3, good. So you have to check where I3 is, detach one end, connect this cable, and then plug in here and let's see. Where is I3? Check it out. Good. So just take it easy. You can see how it is. So detach. Very nice. Hold it. Use one cable connect. Yes. Right? So you now have two terminals to measure. Yes, to measure. Very good. So we are going to connect. Check which one is positive and which one is negative. And connect to the digital multimeter. Okay. Good. That's negative, right? Sure? Don't blow us up, right? Alright, good. So, turn it on. The power. Turn this guy on. See? Change the terminal. Okay. Okay. Good. So what was it giving you? Tell us. Tell me. Speak out.
0.20.
0.20. All right. Thank you very much. I think I see. Thank you. Now, somebody else. Hello. Come. You do experiment. Sorry, not experiment. You do Thank you. Good. So let's disconnect it so that in order to avoid confusion, put them back. Disconnect this guy. Put this one back. Our circuit is good to go again. So I4, check for I4. Yeah, very good. That's I4. So just one part, you have that cable. Yeah, very good. He knows what he's doing. He's very fast about it. No, let's use this one. Yes. Check for the positive and negative. This one is positive. This one is positive. I'm going to call on somebody else now to come and do I5. Thank you, my brother. Turn it on. Thank you. What's it giving us?
0.7.
0.02. Thank you so much. Go and have your seat like a king. Yes. Which one again? Now, I5. You people don't want to look at me again. You were looking at me when I said who is going to do high five. Everybody turned their faces away. Why? You don't want to see my face again? Okay, let's disconnect this guy. Put this one back. And we are good to go. Nice. High five. Very good. You guys are following. So, you detach one end, remember? That's yeah, with R5. Yes, that's R5.
Do you detach the one before or after?
And
Do you detach the one before or after the?
do I want discharge?
Detach the one before or after the resistor?
No, you need to detach first to be able to connect now. I know you asked me a question and I'm not supposed to answer. In fact, you thought to play smart, but I understand. I have to answer. Yes. So you now have 2 times, yes, 2 points to measure. So check out the one that is, I think this one is negative, yes. Yeah, that's negative, yes. Why?
You didn't show it to show it to me.
Are you kidding me? I didn't show you. Are you serious? Are people showing up here? Are you seriously speaking out? Did you hear yourself? Can you imagine? People came up here. 2 people came up here and I didn't tell them anything. And they saw it and we were here. Even people behind said,
Somebody show it to us.
hey, don't say what I didn't do. Be careful, my brother. Turn it on. So, why have it there?
0.02.
Thank you. So, that is the end for the current measurement. Now for voltage measurement, again, we are going to do it. I'm going to do for V1, and then I'll call on people again to come and do V2. Okay? The rest of it. So let's disconnect this one. Complete. Now, you'll be needing 2 cables. You know that already. To measure voltage, you'll be needing 2 cables because you're measuring across. Listen up again. I'll be calling people again. Even if you've done before, you may still come out. So, where is V1? Again, this is R1. You connect. Okay? So, we take it to V, right? We take it to V. Remember. And then that's the real start. We take it to V. We've been doing this one all along. So, this is not a fixed experiment. Now, where are we supposed to put the positive for V? Thank you very much. You see? So, even if it's one person that says it, he has been coming to class. I know him. Even the rest of you have been coming. So, if one person says it, then you have done it. So, the positive, first of all, will say I did not show them. You guys should be careful what you say because you need to. If you cannot remember, doesn't mean that you were not shown or taught. It's different. So, we turn it on. Now, this one is for V1. Remember what I just did? See? Across. I'm going to call somebody else. See? Should I repeat myself? No. See? Because it's the same thing. All this connection. From Ohm's law. So I've been doing it. Thank you for acknowledging. Turn this one on. Reference voltage 5 again. You're not touching it, just 5. So what was the value there? Help us. 2 points. 2 points. 3.5. Okay. Come on, help us with V2. So no need disconnecting any. You can just leave it here so that people will not get confused. You cannot leave it here. Look for R2. No, that's R3. R2 is somewhere. Yeah, that's it. So look up. You're not looking now. Good?
Okay.
So just pause the power button. 2 points.
2.35.
Thank you. 2.3. 6. 6 now, right? Yeah. It's from 20. Yeah, no big deal. We are coming, we are there. So, R3. Come on, try. No big deal. Nobody's beating anybody. We are all trying to learn. Let me put this one here for you. So look for R3, so that's R3. Look up. R3. The smaller one, yes.
Okay.
Good. Very nice. Yeah. Okay. Press the power button. What's it give you? Drop.
0.21.
Alright, thank you. Thank you. 0.21. Come on, try. R4, and then you do R5. V. So there's this detach. That's it. Where is this guy? Okay, this one is fine. That's fine. Okay. 0.21. Okay, thank you. Okay. Okay. Come on. You don't want to take it. You want to escape?
No.
Alright. So R5. So stop right now. This is R5. Okay, that's yeah. Yeah, good. Plug in. No, I just plug. No which one is positive. I don't know. The cables are too much. Yes, good. Very good. So turn it on. Let's see. Okay, it's negative. Change the polarity. Easy. Hold on, please. Something. Where's this voltage? Okay. Can you connect with this one?
Sure.
Connect with this. Thank you. So let's put it down here. Okay. Let's see. 0.00. Let's put it. Let's do something. Let's do something. Because as you know, we are trying to. These are our parameters. Now, for this node, for the current, let's check something out. For the calculations, you do it. You know how to do it, right? V over I, right? For each of the resistors. So you put those ones out. You do the calculation yourself. So you, of course, will mark that. Okay? Now, for this current, let's check this out. Now, this one is I1, right? What's our I1? Please tell me. No, that the I. 0.23. Good. Now, what is our I3? 0.20, yes. Please don't mislead the community. What's I4? Plus 0.02. If you add this guy up, what's it giving you? Sorry, 2, right? See? Are you seeing it?
Yeah.
So it's actually 0.02 that went in through I4. Why? Do you know why? Because of the resistance. You can see resistance there. 9. You see that? So little or minute current flowed in through that guy. And then because your what do you call it? Your R3 had the resistance was lesser. It's almost 1 there. It's almost 1. It's almost 0.1 kilo ohm. So more current had to flow in. You can see that. But the summation, the total current that flowed in through I1 was 0.02. Sorry, 0.23. You get the point? So this is a tip for us there. So remember, milliamp. Let's go for the one beneath. I2, what's your I2? 0.23, right? Thank you. What's your I3? 20, right? Where is this mark? Sorry. 0.20 plus. Now you see your I5 there. You're having 0. So this guy, the problem is this resistance. You see, it's so low. It's not even up to 0.1 like the rest of them. You understand? So it's like the current is actually negligible. The current flowing, you get it? So we are supposed to, that I5 is supposed to be around, the one we usually have is close to 100 kilo ohms. So some amount of current will still pass. Or sometimes, no, I think it's 0. I'm not entirely sure, but it's like it's higher. It's obviously, yeah, it should be higher. It should be like 10 or 100 thereabout. This guy normally, but unfortunately we didn't see anyone here, so we have to implement that. So naturally, as you can see, this resistance is exceedingly low. Even this one, you can see this guy is having something like this. You see? And you can see that it's different from this one, actually. But you know why? Do you know why this one is higher than this one? Who can tell me why? According to that circuit diagram, there is something very interesting here. Both of them are having almost the same resistance. Am I correct? Now, who can tell me why this current is much higher than this guy? According to that circuit diagram. Tell me. Yes.
I don't was connected to other resistors.
Perfect. That's just, yeah, giving you the answer. Because the first resistance, the first current that will flow in through that R1 is directly from the source. So it has gathered everything, and then your brother has just told you why. Because it's split, you have to share some because 2 other resistors are connected to it. So experimentally, you have been able to see what's happened. What happens is when resistors are connected. Experimentally, we've been able to see according to this very simple circuit diagram. So we've seen that if this one is this is that, some of them will be more, some will be less. You get it. So we've been able to verify at least that the voltages and currents, they vary. Alright? It's not so uniformed according to the voltages. Yes. It's not so uniform, but it varies. So that's why they just told us the aim was let us see what's going to happen. Let's see. You get. So in your concluding aspect of your report, you can, whatever you noticed here, especially from this explanation, for those of you online as well, from this explanation we are giving to you, you can see that one or two things are adding up, some are not adding up. You understand? Just make it flexible. Make your text flexible. Write something interesting and something related to what we did in the lab. Don't get something from the internet. If you get anything from the internet, I'm going to give you 0. I'm still going to emphasize on the reports. After this, when I'm sure there's no more question, I'm going to emphasize more on the reports. Because we are seeing so many funny things. Of course, some of you are doing perfectly well. But some of you, again, don't listen. And you do whatever you like. And you submit whenever you like. It's not right. Again, you are all prospective engineers. Nobody is a management student here. Nobody is doing economy here. Nobody is doing banking here. So you need to act like one. Tomorrow you start receiving massive salaries. And then you tell your children, you don't know what I went through. And then now you're doing anyhow. What will you tell your kids? Eh? This young woman is laughing. That's an engineer too. You guys should behave like one. Honestly. The way we see you, the way you guys construct report. Some of you, like I said, you guys are, man, you are there. But the way some of us again construct reports very poorly. And when you tell them that this is a mistake, they will still be confused. And they will ask you why they made that mistake. Some of them. You see, you are shaking your head. This is what we see. This is the kind of messages we see, and we try to explain, but it's still not clear. Nobody is saying anybody's, none of you are dumb. No, none of you. All these engineering students we have, all of you are very smart. But most times, you want to play on our intelligence. Because you are, of course, students are lazy. I can be very lazy. I can be very lazy. So, because we are lazy, let me categorize. You don't want to do the right thing. You just want to fast. You send us pictures. Listen to this. You come here, stand here, and snap this ball. And then send it to us to mark. You see? You see what I'm saying? This is what we see. You guys are smiling. If you see it, you want to cry. And then when you tell them you made this mistake, they will reply and say, why didn't you tell us to type? You know, sometimes I say, well, it's on video, right? Mm-hmm. I'm sad when you try to talk to this, when you try to explain, and then they will not want to get it. They just want to keep arguing. It's not right. You know, they know the right thing to do, but they don't want to do it. The brain is there. All of you are very smart, but you just don't want to do the right thing. And it's very painful. Somebody brought me a report to my office. He said he did not type. Listen to this, he didn't type. He wrote. And I told him, do you want me to give you 0? He said, no, sir. You know what you did wrong? He said, yes. What did you do wrong? He said, I did not type it. And I took it. I couldn't speak again. He just took it and left. You see. Brought the report, wrote it with handwritten. I couldn't even see the writing. I said, I'm going to give you 0 for this. Sir, no, please. You know why? You know where you went wrong. He said, yes. Why? Sir, I didn't type. I didn't say anything, just took the report and left. And he submitted neatly typed report. See? The only image you want to see, in your report can be the circuit diagram. Some of you may not know how to use Microsoft Word to draw. The only image, listen, and listen carefully, because you have experiment 4 and 5 to amend your weights, especially in these reports, to get the maximum score, if possible. The only images we want to see is, that's in your report, is the circuit diagram. The rest of it should be neatly typed. You already have a table of content, you know what to do. If you miss something, if one is missing, of course, marks will be deducted. And if you don't do one section properly, marks again will be deducted. And we tell you what the problems are. When some of you ask, we tell you. Well, of course, some we tend to argue. Some, very little, not like maybe 10%. Most of you, when we say this is it, they agree. So, for better report, don't give us images of the table. Don't give us images of your calculation. You're going to get 0. We have been giving you scores. We have been lenient, giving you scores even if you see the images. Some of you. So, but is it not fair to others that have typed? It's not fair. I need to just say it. Some of you that give us images of the calculation, your conclusion, we give you marks. I'm sorry about those. I'm trying to be apologetic to those of you that typed. Okay? It's not fair to you guys, but we just gave those other ones, those guys that gave us the pictures, a few points. Now, to all of you in general, if you give us images, this video will be uploaded. If you give us images of your reports, images, you get 0. I just hope that the ones online will finish this video, because they rarely finish the video. When they upload like 2 minutes, they go and sleep, and then they will do whatever they like. Any question?